for aerodynamic center, we're going to look at, I'm going to say this is very cambered, even if it doesn't necessarily show it, and we get a lot of lift at 0 angle of attack. So forget that. We're at 0 AOA. And here we get very little, minuscule amount. Then at a higher AOA, we have some added lift and added lift. So here is the breakdown that we will do. This box will represent the lift at cruise. And so the area is calculated using the lift equation. You have CL alpha of the wing times the incidence angle, gives you the lift coefficient, times Q bar S, gives you lift. Here, the incidence angle for the horizontal stab times the lift curve slope of the horizontal, Q bar SH. And so this is a smaller width because the area is smaller on the horizontal stabilizer, and the lift curve slope might be smaller too. All right, and these are supposed to be on the same line. Use your imagination. Okay, now we look at the component of the added lift. So here's our angle of attack. We started at 0, and so the black is the trim case at 0, and now this is our absolute angle of attack. We'll say it was 5 degrees. So we add 5 degrees alpha right through our equations to both of them. So the center of the red box is the center of the added lift. If we look at the actual area here, right through the equations. So that is our aerodynamic center. And that's the center of our added lift. Now, the center of lift, absolutely, like as in for a particular case, we can talk about that too. So we started off at trim. The center of lift is the center, or the average of this black area and this black area, which is somewhere around here, we'll say, center of lift. And then at the higher angle of attack, we have to include all of the area that we drew. Black plus red, black plus red. So it moved closer to the aerodynamic center. This is the center of lift at 5 degrees. Center of lift at 0 degrees. It moved closer to the aerodynamic center of the vehicle, also known as the neutral point. And as you keep increasing the angle of attack, the red boxes are going to be weighted more and more than whatever the area is in the black boxes. And so you'll asymptotically approach the aerodynamic center with the center of lift. But the point is, right, you have your free body diagram, you have your weight, and you have the lift balancing it. And so then whenever you look at what the effect is on the added lift, you know it's being added at the aerodynamic center. And so this, if it's behind the way I've drawn it, behind the center of gravity, has a pitching down moment associated with it for a positive lift. So that means if you get disturbed positively, you increase the angle of attack, you get a negative pitching moment. That brings you back to equilibrium, and that's restoring. So that's stable. So this is stable as I've drawn it.